Hello, dear students. So, let us continue our discussion with the isomerism in coordination compounds. So, we know that the isomerism means the two or more compounds having the same chemical formulae but differ in the physical and chemical properties. So, due to the different structural arrangement are called as the isomers, and the phenomenon is known as the isomerism. So, based on the structural arrangement, so the isomerism can be classified into two types. So, the first one is the structural isomerism. So, in case of structural isomerism, so the two or more compounds will be having the same chemical formulae but differ in the physical and chemical properties due to different structural arrangement of atoms in a molecule. So are called as the structural isomers, and the phenomenon is known as the structural isomerism. So let us move on to the types of structural isomerism. So structural isomerisms are further classified into the ionization isomerism. So in this type of isomerism, so the different ions are produced when the a complex is dissolved in water. So the two or more compounds will be having the same structural formulae, but when the compounds are dissolved in water, so they dissociate into different ion. So here you can see in the first complex, okay, so the complex dissociates into give a complex ion containing the cobalt 5 amino ligands and one bromine atom, and the second complex so dissociates into give the bromide ion. So both the compounds, the complex compounds have the same molecular formula, but when they are dissolved in water, so they give different ion. So such isomers are called as the ionization isomerism. Ionization isomers, and that phenomenon is known as the ionization isomerism. So that means two or more compounds having the same molecular formula, but when they are dissolved in water, so they undergo ionization to form different ions. So that's why it is called as the ionization isomerism. So the next type of isomerism is hydrate isomerism. So that means, so in case of hydrate isomerism, so the two or more compounds will be having the same molecular formula, but they differ in the number of water molecules, so which acts as the ligands. So here you can see in the first complex, so there are 6 aqua ligand, that is water molecules are present. So in the second example, so 5 water molecules are present inside the coordination sphere and 1 water molecule is present outside the coordination sphere. So in the third example, 4 water molecules are present inside the coordination sphere and the 2 water molecules are present outside. So therefore, in the first example, so if all the 6 water molecules are present in the coordination sphere, the color of the complex will be violet. So while one water molecule it is present outside, the color of that complex will be green. Okay. So in case of the third example, that where the 2 water molecules are present outside, so the color of the complex will be dark green. So next let us move on to one more type of isomerism. So that is linkage isomerism. Okay. So in case of linkage isomerism, the compounds will be having a same molecular formula. Okay. So in this case of isomerism, so the different atoms of the ligands act as the ligating atom. Okay. So here you can see in the first example, so the nitro group, is acts as the ligating atom. So the nitrogen atom of the nitro group is linked to the, or it has been formed the coordination bond with the cobalt. Okay. So that nitro group, it's an ambidentate ligand. So the either oxygen atom or the nitrogen atom will act as the ligating atom. So in any complex, if the nitro group is present, so either nitrogen can bond with the central metal atom or ion, or oxygen atom can bond with the central metal atom or ion. So in these two examples, you can observe in the first example, the nitrogen atom of the nitro group is the ligating atom. So whereas in the second example, the oxygen atom of the nitro group is the ligating atom. So that is called as the linkage isomerism. Okay. So the different atom of the ligand will act as the donor, act as the ligand atom. So that is called as the linkage isomerism. So in the second example, so you can see the thiocyanato ligand. So in the first example, the sulfur atom of the thiocyanato ligand is linked to the cobalt. So whereas in case of the second example, the nitrogen atom of the ligand is linked to the cobalt. So therefore two different atoms, the ligand, the same ligand, the two different atoms are linked to the central metal atom or ion. So the next type of isomerism is the ligand isomerism. So this is also a type of structural isomerism. So where the same ligands undergo different isomeric forms. So which is called as the ligand isomerism. So here you can see in the example, okay. So the ligands, so which are present. So in the first example, so the cobalt is the central metal atom or ion. Okay. So in the two examples, so the ligands, so the isomeric forms of the two ligands which are present inside the coordination sphere are different. Okay. So here you can observe the NH2 groups present which acts as the ligand. Okay. So this is 1, 2 diaminopropane. In the second example, it is 1, 3 diaminopropane. So that means in the first example, the ligand, the amino group is present at the one and the second position, first and the second position. So whereas in the second example, the amino group is present at the first and the third position. So therefore the ligand is the same ligand, but they are in the isomeric form, different isomeric forms. So which is called as the ligand isomerism. So the next one is the coordination isomerism. So this is also an example of structural isomerism where the interchange of ligands, so between the two cationic and the anionic coordination spheres takes place. So that is interchange of the ligands between the cationic and anionic coordination spheres. So here you can see in the example number 1, so the 4 amino ligands are present inside the coordination sphere and 4 chloroligands are present inside the coordination sphere. So in the second example, what happened? So the chloroligands which are present with the platinum, now they are present with the copper, and the ammonia ligands which are present with the copper are now they are present with the platinum. That means the ligands are interchanged in the either cationic or anionic coordination spheres. So in the second example, you can see the 6 amino ligands are present with the cobalt coordination sphere and the 6 cyanides are ligand in the chromium coordination sphere, and the second and the its isomer, so the 6 ammonia ligands are interchanged with the chromium and the 6 cyanide ligands are now with the cobalt. So the interchange of the ligands inside the either cationic sphere or anionic sphere, so is known as the coordination isomerism. Okay. So next let us move on to the stereoisomerism. So in case of stereoisomerism, so two or more complex will be having the same molecular formulae. So but they differ in the physical and chemical properties, having the because of the different spatial arrangement of atoms. Okay. So different spatial arrangement of atoms. So the stereoisomers, they are called as the stereoisomers, and the phenomenon is known as the stereoisomerism. So the types of stereoisomerism. So based on the different mode of spatial arrangement, that is based on the arrangement of the spatial arrangement of atoms. So the stereoisomerism can be classified into two types. So the first one is the geometrical isomerism or cis-trans isomerism. So the complexes in which have the same molecular formulae, but they differ in their relative position of the ligands about the central metal atom are called as geometrical isomerism. So that means the spatial arrangement of the ligands around the central metal atom or ion will be different. Okay. So let us consider the two complex compounds, that is diamine dichloroplatinum, diamine dichloroplatinum complex. So here we have two amino ligands and two chloroligands. So in the first example, two amino ligands are present on the same side and two chloroligands are also present on the same side. So therefore the isomerism is known as the cis isomer. So in the second structure, so the two chloroligands are present on the opposite side and also the two amino ligands are present on the opposite side. So therefore this isomer is called as the trans isomer. So in the second example, so that is tetraamine dichlorocobalt ion. Okay. So the two amino ligands are present on the same side. Okay. So in case of the second example, the trans isomer, so they are present on the opposite side. So in case of the dichloro bis ethylene diamine cobalt 3 ion, so you can, so that is the first one is the cis isomer and the second one is the trans isomer. So these are the examples for octahedral complexes. Okay, so the ethylene diamine. So let us move on to the one more type of isomerism, that is optic. So the ability of the complex to rotate the plane polarized light is called as the optically active compound. The complex that rotates the plane polarized light in a clockwise direction, that is towards right, is called as a dextrorotatory, or it can be called as a D form, and the complex which rotates the plane polarized light in the anti-clockwise direction or towards left, so which is called as the levorotatory, that is L form. Okay, so the D and L form of the complexes are generally, they are a mirror image of each other. Okay, so the complexes which have the same molecular formula, the same chemical properties, but differ in the rotation of the plane polarized light are called as the optical isomers, and the phenomenon is known as the optical isomerism. So the tris ethylene diamine cobalt 3 chloride ion. So the first structure is the D structure which rotates the plane polarized towards right, and the second structure is the L form, so which rotates the plane polarized towards left.